Assalamualaikum and greetings to Lajak Laku Top Management. Our group will be presenting Lajak Kuruih Production Report for Tablet C. Our group consists of me, Nurhayati Khalid, Nurafifah Lotfi, Akhmalia, Hekmal, Hisham and Aisha Jamal. So this presentation will be divided into 6 parts, including the introduction and conclusion. So I will start with the introduction. First of all, the problem having by the tablet manufacturing operations are fluctuations in tablet weights and inconsistent tablet hardness. So the objective of this data analysis is for monitoring and describing the quality of tablet production for a particular type of Lajak Kuruih tablet. And about the data, we got 200 samples of tablets for pil Lajak Kuruih C in December 2020 from 3 production shifts that are morning, evening, and night. And the method that we used for each part are Excel graphical analysis, chi-square test, ANOVA, and regression. So I will continue with part A. Okay, as you can see, the table at the top right of the slide is about the mean and standard deviation for weight of tablets based on shift, while the other table is about the data analysis for weight of tablets regardless shift. And the standard deviation for evening shift shows the lowest value of standard deviation compared to the other shift, that is 12.64124. Okay, it indicates that the value of data points is just around the mean of evening shift, that is 348.4004, while the night shift shows the highest value of standard deviation, that is 14.30363, meaning that the data points widely spread from the mean of the night shift, that is 349.65. And then the maximum weight of tablet is 393.33 milligram in morning shift, while the minimum weight of tablets is 317.82 milligram in night shifts. And then the graph, as you can see, this is a graph of frequency and the range of the weight of tablets. And the highest frequency is 61 in the range of 340 and 350. Next is the data analysis of tensile strength in megapascal. Again, the standard deviation for tensile strength in evening shift shows the lowest value, that is 0.1840, compared to the night morning shows the highest standard deviation, that is 0.2079. And then the maximum value of tensile strength is 7.7 megapascal in night shift, while the minimum tensile strength value is 6.6 megapascal in morning shift. And then the graph, you can see that the highest frequency is 82 in the range of 7.0 and 7.2. And this is like a bell shape, almost like a bell shape, but there's one frequency in the range of 7.6 and 7.8, but it's still a good shape of histogram graph because the mean and median is closer to each other. That is, the mean is 7.152 and 7.1 for median. And then next is the data analysis of relative density in percent. And then the standard deviation for the morning shift shows the highest standard deviation, that is 1.9788 compared to the other. And then the mean for the morning shift is 87.9934. And then the maximum value of relative density is 93.3% in morning shift, and the minimum relative density is 82.8% still in morning shift. And the maximum The maximum frequency is in the range of 86 until 88. Okay. So next, Aisha Jamal will continue with part B. Thank you.
Assalamu alaikum. My name is Aisha Jamal and I'll be presenting part B. Now the overview is that the objective of part B of the question is that we have to calculate whether the weights of the Lajak Ssce tablets follow a normal distribution with a mean of 350 milligrams and a standard deviation of 14 milligrams. So to decide where to check whether this follows a normal distribution, we'll perform the chi-square test on the weights with the assumption that the weights do follow the normal distribution. And then we'll use a significance level of alpha equals 0.05. So if the p-value that we find is greater than 0.05, then we can accept that the weights do follow a normal distribution. This is a hypothesis statement. The null hypothesis is that the tablet weights follow a normal distribution of a mean equals 350 milligrams and a standard deviation of 14. The H1 hypothesis is that the tablet weights do not follow a normal distribution. Now, before running the chi-square test on the data, we first need to sort all the values into a frequency table because there are 200 values. So we'll divide them into different categories with intervals of 10, 315 to 325 milligrams, 325 to 335 milligrams, and so on. And as you can see, there are 8 categories with the frequencies listed below. Now the frequency of the tablet weights in each category is known as the observed number. Now the chi-square formula, as you can see, is the expected value minus the observed value whole square divided by the expected value. Now we've already seen the observed value as the frequency in the table earlier. So to find the expected value of each category, we need to use the formula Z is equal to X bar minus the mean divided by the standard deviation. Now using this formula, we can find the area under the graph for each of the categories mentioned. And when we multiply it by the sample size, which is 200, that will give us the expected value of tablets in each weight class, in each weight interval. So then after we find that, to find the chi-square value, we just need to apply the formula for each category and then sum it up. And this is the statistical table showing how it works. The class interval, the observed number, the area on the graph for each class interval, and here we've calculated the expected values, expected values for each category, the expected minus observed whole squared and divided by the final expected number. Now the last column we will sum up to find the chi-square value of 3.7054. Now that we found the chi-square value, we need to find the degrees of freedom as well and then use that to find the p-value. And now when we were calculating the chi-square value, we were using 2 parameters to calculate it, the mean and the standard deviation. So the degrees of freedom will be equal to the number of categories we have, which is 8, minus the number of parameters we used, which is 2, minus 1. So our total degrees of freedom is equal to 5, and our chi-square value is equal to 3.7054. Now to find the p-value, we'll plug in these two numbers in the statistical analysis, and we get a p-value of 0.5925. Now the alpha value we were using was 0.05, and the p-value is clearly larger than the alpha value. Therefore, we can accept the null hypothesis with 95% certainty. So in conclusion, the tablet weights do follow a normal distribution with a mean weight of 350 milligrams and a standard deviation of 14 milligrams.
My name is Nurafifah. I will continue to explain about part C. Which question is about, is there any significant difference between tablets weight from the different shift? The method that we use to answer this question is by using one-way ANOVA in Microsoft Excel. The purpose of doing this is to decide if there was any significant difference between tablet weights from the different shift. Firstly, we need to sort the data into three shifts, which is morning, evening, and night, with the value of table weight in the column. Then, we use ANOVA in data analysis to create the summary output. From this summary table, it shows that the value of sample for every shift, which is morning, is 61, while evening is 71 and night is 68. It also displays the value of average and variance for every shift, while in the ANOVA table, in the column of source of variations between and within groups is also known as treatment and error value. SS means sum of square, DF means degree of freedom, while MS is mean of square, and F indicates the value of F test. We use p-value to check whether is there any significant difference between tablet weight from the different shift. Then p-value is compared with level of significance alpha is equal to 0.05. If p-value greater than alpha means we fail to reject HO, but if p-value less than alpha, it indicates that we reject HO. From the output summary, the p-value is equal to 0.83555787, which is greater than alpha 0.05. Therefore, it means we fail to reject HO. We can conclude that at alpha 0.05 level of significance, that there is no significant difference between tablet weight from the different shift.
Assalamualaikum. My name is Akhmalia binti Hisham. I will explain for part D, which is to predict the relative density and tensile strength in Lajak Kuruih for table C. From this slide, we can see the table that show the relationship between the relative density and tensile strength in table C regardless of the shift. Okay. The relative density in percentage is the independence variable or called predictor, and the tensile strength in MPa is the dependent variable or called response variable. This table is 200 sample data from month of December 2020 from relative density and tensile strength. Next, we will conduct linearity tests to check if the relationship between relative density and tensile strength is linear or nonlinear. The equation to describe this relationship is y equal to mx plus c, which is y is the tensile strength of peel in MPa, m is the gradient of the line in ratio, x is the relative density of peel, and c is interception. So, from that, we can do the simple linear regression equation, which is yi equal to alpha plus beta xi. And the linear regression for the relative density versus the tensile strength that we obtain is y equal to negative 0.509498695260685 plus 0.0x69251828958881x. And next, the value of alpha, we take the 4 decimal place, which is negative 0.5095, and beta is 0.0x69. All this we get from the Excel analysis model which is to estimate linear equation coefficient. From this table, as you can see, intercept is for C, or what we call is for strength, and relative density is for X. This observation, which is N, is 200 data, and from the predictor that we done for 68%, we get the tensile strength is 5.4041, and for 74.3% relative density, we get the tensile strength is 5.9490 MPa, and for 80.1% relative density, for the tensile strength that we get is 6.4532 MPa. From this graph that we get, it shows that we get the linear linear for relative density and tensile strength. Okay, next, the estimation error. I will explain. This estimation error is the equation that obtained is counterintuition from the Excel that we done, and the tensile strength should be 0 when the relative density is 0. So the value of intercept C should be at 0. The reasoning that we get for relative density, which is relative density equal to density of peel times 100% dividing by density of reference material, and density is equal to mass of peel divided by volume of peel. So that we get that relative density of 0 means there is no peel that is tensile test. Tensile strength data should be 0 when no test is carried out. Next, for hypothesis test that we get from this graph is result conclude is the validity of intercept value C is 0 with 95% of confidence. Okay, next, this is the output graph that we get from Microsoft Excel for linear regression model from relative density line fit plot, relative density for residual plot, and normal probability plot. So the conclusion that we can make is the table weight follow normal distribution means equal to 350 milligram, and the standard deviation that we get is 40 milligram, and there is no significant difference between the tablet produce different shift, and the linear regression model is a valid model to predict the test result of the tensile strength of the peel based on its relative density with up to 95% accuracy. That's all from me. Thank you.